Okay, we're going to find the limit as h approaches 0 of f of 3 plus h minus f of 3 over h of this function, right? X squared minus 1. Now, we did this kind of thing in the very first chapter, if not the very first section in the very first chapter. We were doing difference quotients. We weren't taking limits of difference quotients, but we were doing difference quotients. If you look at the slides we used last class, I mean, remember, the difference quotient is what we use to find the slope of the tangent line by approximating, taking 2 points. Here's that's x, f of x. This is x plus h, f of x plus h. And we do the y2 minus y1 over x2 minus x1, you get that. It's an equation for the slope. Right? The only difference in this problem that we're doing right here is that they've actually, for x, they're saying x is 3. We're trying to find the slope at the point x equals 3. So if you look back, right, that point is 3, which is fine. I personally don't like it. I prefer to just do x plus h, but 3 plus h will work too. Okay, so if you remember, when we did these, the hard thing was always doing the f of x plus h, or 3 plus h. That's always where we made our mistakes. How do you find f of 3 plus h if f of x is x squared minus 1? Say again, Buck? Yeah. Well, in the place of the x here, put 3 plus h, right? So that's 3 plus h squared minus 1. Now, that could be simplified. Right? That is 9 plus 6h plus h squared minus 1, which is 8 plus 6h plus h squared. Okay, we will use that here. Okay. Now I need f of 3. Right. F of 3 equals 3 squared minus 1, which is 8. Okay, so we are finding the limit as h approaches 0 of 8 plus 6h plus h squared minus 8 divided by h. No, you simplify. Look at the numerator. What could you simplify? Sandy? 8 minus 8 cancels, right? So this is the limit of h approaches 0 of 6h plus h squared over h. Then what can you do? There's a common factor of h in both terms in the numerator. If it helps, you could write it like this. The limit as h approaches 0 of h times 6 plus h divided by h. Right? And then the h's cancel. So that is the limit as h approaches 0 of 6 plus h. Now try direct substitution. What do you get? 6. And if you use those techniques that I used over there, right? If this is the function, right? F of x equals 2x equals x squared minus 1. 1 is a constant, right? Which means it's like x to the 0. So the derivative of a constant is 0. Because you go 0 times, if that term drops out. So the derivative of this would be 2 times x. And at x equals 3, since that's where we want to find the slope, 2x equals 6. So that's what we found. You just take the 2x, and since we're finding the slope at x equals 3, then plug in x equals 3, and you get 6. So this is the long way around. That, again, you won't do routinely. You'll do a lot at the beginning as you're just getting started in calculus.